Your Ford F-150's EcoBoost turbos are being systematically destroyed right now by habits and settings most owners consider completely harmless. I've been diagnosing and repairing turbocharged Ford engines for over 15 years. I can tell you straight that turbo failure on these trucks is almost never a case of bad luck. It is almost always caused by the same 4 or 5 routine owner behaviors, repeated thousands of times until the damage becomes completely irreversible. Today, I am exposing every single one of them. A replacement turbocharger on the 3.5-liter EcoBoost costs between $2,000 and $5,000 per unit depending on labor. You have 2 of them sitting under your hood before we look at the specific behaviors in your hardware. You need to understand why these units are uniquely vulnerable compared to every other component in your engine. The twin turbos on the 3.5-liter and 2.7-liter EcoBoost spin at over 150,000 revolutions per minute when your truck is working hard. That is not a typo. The only thing keeping that turboshaft from instantly destroying itself at those extreme speeds is a pressurized film of engine oil floating between the shaft and the bearing housing. That oil film is approximately 1/1000th of an inch thick. It is literally thinner than a single human hair. Remove it, degrade it, contaminate it, or interrupt it for even a few seconds at high speed, and the shaft makes direct contact with the housing. Metal touches metal at 150,000 RPM. The resulting damage is rapid, catastrophic, and incredibly expensive. Every single behavior we are about to break down compromises this tiny boundary layer. Setting 5. The factory oil life monitor, the first silent killer, destroying your turbos, is running extended oil change intervals. This is a massive issue where Ford's own factory software recommendations are actively working against your wallet. Ford programmed the intelligent oil life monitor in modern F-150s to suggest oil change intervals that can stretch up to 10,000 miles under certain driving conditions. That interval might keep fleet maintenance costs looking low on paper for a naturally aspirated V8 engine, but it is genuinely dangerous for a high-output, turbocharged EcoBoost in real-world truck use. Here is the mechanical reality. Your turbochargers run at extreme temperatures and place enormous thermal stress on the oil flowing through the bearing housing. Under heavy boost, the oil temperature inside the turbo center section can spike to 300 Fahrenheit or higher. At those extreme temperatures, oil begins to oxidize rapidly. The long-chain polymer molecules break down into shorter, weaker molecules that provide drastically less viscosity and reduced film strength. The oil gets dangerously thin. That crucial 1/1000th of an inch film between the shaft and the bearing housing begins to collapse. Compounding this issue is the EcoBoost's known tendency to create blow-by soot and combustion byproducts. When you stretch your oil changes to 10,000 miles, these fine abrasive particles accumulate and continuously circulate through your turbo bearings. Ford technician and EcoBoost expert Brian Machulo has documented this exact failure mechanism on a real customer vehicle. The engine failed prematurely at 224,000 miles due to extended oil change intervals. Blow-by soot accumulated to the point where it completely blocked the microscopic turbocharger oil intake screens. With the screens blocked, total oil starvation destroyed both turbo units, the economic reality. A routine $60 full synthetic oil change every 5,000 miles is the cheapest turbo insurance money can buy. Skipping it to follow the dashboard monitor might save you $120 a year, but it sets you up for a $5,000 turbo replacement bill down the road, the actionable fix. Ford specifies 5W30 full synthetic oil for the EcoBoost because it resists flame breakdown far better than conventional blends. Disregard the dashboard oil life monitor completely. Change your oil every 5,000 miles without exception. Shorten that interval to every 3,000 to 4,000 miles if you tow regularly, make frequent short trips, or operate in extreme heat. Setting 4. The unfiltered PCV vapor loop there is a closely related mechanical flaw that compounds your oil contamination problems significantly, and most truck owners have no idea it is happening right inside their intake tract. First-generation EcoBoost engines from 2011 through 2016, and even the newer dual-injection blocks, generate high amounts of crankcase blow-by. This occurs when highly pressurized combustion gases and vaporized oil force their way past the piston rings and enter the crankcase. The positive crankcase ventilation system is designed to route this volatile vapor back into the intake tract so the engine can burn it off for emissions compliance. The massive flaw here is that this vapor carries a fine, sticky oil mist directly into your intake components. This mist circulates through the entire intake system, coating your turbocharger compressor housing, your intercooler, and your intake valves. Over tens of thousands of miles, this oily residue cooks and carbonizes. It gradually restricts the tiny oil supply screens that protect the turbo bearing housing from debris. When these screens become restricted, oil flow drops, the bearing film thins, and the turbo runs on inadequate lubrication while spinning at 150,000 RPM. Bearing wear accelerates silently. Because this damage happens gradually over years, you will never feel the exact moment the destruction begins. The problem, unfiltered oil vapor, bakes onto critical oil supply screens and intake valves. The consequence, restrained oil delivery causes bearing wear, shaft play, and eventual turbo lockup. The cost, $150 preventative part versus a $4,000 dual turbo system overhaul. The actionable fix. Install an aftermarket oil catch can inline with your PCV system. Even Ford Performance Parts acknowledges this issue by selling their own catch can kits. Utilizing part number M676635T for 2017-2020 trucks and M676635TA for 2021 and newer models. High-quality options from J&L or Mishimoto install in under 30 minutes with no permanent modifications. The catch can intercept the PCV vapor, condenses the oil droplets, and stores them in a reservoir you simply empty at every oil change. Setting 3. Immediate engine shutdown. The third highly destructive habit destroying EcoBoost turbos right now is shutting the engine off immediately after highway runs, hard driving, or towing. This single behavior is responsible for more premature turbo bearing failures in my shop than almost any other factor. The root cause is a catastrophic thermal phenomenon known as oil coking. When you are towing a heavy trailer or accelerating hard down an interstate, your turbos work near maximum capacity. This creates massive heat inside the center bearing housing. The engine oil flowing through that housing continuously absorbs this extreme heat and carries it away to the oil cooler. When you pull into a gas station or park at your destination and immediately turn the key off, the mechanical oil pump instantly stops. Oil circulation completely ceases. However, your turbocharger does not stop instantly. It continues spinning on pure inertia for several seconds without pressurized lubrication. Worse yet, the glowing exhaust manifold right next to the turbo housing continues radiating intense residual heat directly into the stationary bearing center section. The trapped oil sitting inside the hot bearing cavity cannot circulate. It sits there and literally bakes from a liquid lubricant into a hard, abrasive carbon crust called coke. These hard carbon deposits permanently coat the mirror-smooth bearing surfaces and restrict the internal oil flow passages. The next time you drive, these sharp carbon particles score the spinning shaft. The shaft develops physical play. The compressor wheels start clipping the housings. Your boost pressure drops, and you are left with a massive repair bill. Hard driving towing Gaio. Extreme turbo heat Gaio. Immediate engine shutdown. Abrasive carbon deposits. Oil bakes, cakes. Oil pump stops trapping oil. Bearing wear and turbo failure. The actionable fix. After any extended highway drive or towing session, let your engine idle for 60 to 90 seconds before you turn it off. This allows the oil pump to continue circulating fresh oil through the hot turbo housings, safely pulling the peak heat away. Alternatively, you can install an inexpensive electronic turbo timer for $30 to $80. This device keeps the engine idling safely for a preset window after you pull the key and walk away, completely automating the cooling process. We have covered how oil maintenance, PCV contamination, and heat management are actively degrading your system. But the most insidious threat to your EcoBoost turbos is a feature Ford intentionally programmed into your truck's computer, and the hidden damage it causes is happening every single time you hit a red light. Setting 2. The auto start-stop calibration flaw, the fourth behavior destroying your turbochargers, is a feature that Ford actively enabled through your vehicle's factory software calibration. I am talking about the auto start-stop system. While most F-150 owners already despise this feature because it causes premature wear on cam phasers, starter motors, and batteries, the hidden damage it inflicts on your twin turbocharger system is far worse and rarely discussed by dealership service advisors. When you approach a red light or sit in stop-and-go gridlock, the engine control module commands the engine to shut down instantly to save a microscopic amount of fuel. The moment that crankshaft stops turning, mechanical oil pressure drops to exactly 0 pounds per square inch. Oil circulation to your turbochargers stops completely. However, because you were just driving a moment prior, the turbos are still blistering hot, and the exhaust gas temperatures in the manifold are still highly elevated. When the light turns green and you step on the gas pedal, the engine fires back up, and you immediately accelerate into traffic. Here is where the engineering nightmare occurs. A turbocharger turbine wheel begins to spin up the exact millisecond exhaust gas hits it, but your engine's oil pump takes a fraction of a second to draw oil from the pan, pressurize the oil galleries, and force that 5W30 full synthetic fluid all the way up to the turbo bearing journals during that critical fraction of a second. Your turbo bearings are spinning under load on nothing but a depleted, unpressurized residual oil film. Engineers refer to this as transient boundary lubrication. Every single time your truck goes through a start-stop cycle, your turbos undergo a micro-cold start event. If you commute through heavy city traffic, your truck might execute this destructive cycle 20 to 30 times every single morning. Over tens of thousands of miles, these micro-abrasion events shave micrometers of material off the thrust bearings and journal sleeves. The myth, auto start-stop, is a harmless, modern fuel-saving feature designed for the longevity of the entire powertrain. The mechanical reality, it subjects high heat, high-speed turbo bearings to hundreds of dry start cycles per week without active oil pressure, the friction window. The turbine accelerates instantly upon combustion while oil pressure lags behind by up to 500 milliseconds, the financial delta over a 5-year period. The auto start-stop system might save you roughly $150 to $200 in total fuel costs based on average idling metrics. Compare that to the $4,100 bill you will receive at the dealership when the internal shaft play gets sloppy enough to send the compressor blades into the aluminum housing. It is a mathematically absurd trade-off, the actionable fix. Make it a strict habit to disable this feature every single time you start your truck. There is a physical button located right on your dashboard console, a capital letter A with an arrow circling around it. Press it immediately after turning the key or hitting the push button start. If you want a permanent solution so you never have to remember it again, buy an aftermarket device called an Auto Stop Eliminator. It costs between $100 and $150, installs behind your dashboard switch panel or OBD2 port in less than 15 minutes, and uses an electronic memory chip to keep the system permanently turned off until you decide otherwise. Setting 1. Cold start abuse and cold climate acceleration. The final and most aggressively negligent behavior killing your turbos is cold start abuse. This means starting your truck after it has sat overnight and driving away aggressively before engine oil pressure and thermal expansion have fully stabilized across the entire engine block. This is a massive point of confusion because modern electronic fuel injection systems are incredibly efficient. Unlike old carbureted trucks, a modern EcoBoost will start up smoothly in 0-degree weather and allow you to drive away instantly without coughing, sputtering, or stalling. But just because the computer can manage combustion does not mean your turbo hardware is ready for a load. Let us look at the precise engineering clearances inside these units. The clearance between the spinning turboshaft and the stationary brass or ceramic bearing sleeve is less than 0.001 of an inch. When the engine is cold, the oil in your oil pan is thick, viscous, and slow to move. On a freezing morning, it takes several seconds for the mechanical pump to push that cold oil through the restrictive narrow feed lines that route fluid up to the top of the engine block where the turbos reside. Worse yet, metals expand when they get hot. The steel turboshaft, the aluminum compressor wheel, and the brass bearings expand at completely different rates. When you start the truck, pull out of your driveway and immediately floor the throttle to merge into fast-moving highway traffic. The engine computer commands the wastegates to close. This instantly forces the turbos to spool up to over 100,000 RPM. Because the oil is still cold and thick, it cannot flow fast enough through the microscopic clearances to provide a hydrodynamic boundary layer. The shaft experiences extreme frictional heat localized on cold metal. The steel shaft expands faster than the surrounding cold bearing housing, creating severe structural binding. This microscopic galling tears away at the polished surfaces. Over a period of several years, this habit creates severe shaft play, leading to oil seals leaking oil directly into your intercooler and exhaust stream, producing that signature blue smoke out of your tailpipe. Cold start, gall thick. Sluggish oil guy, immediate heavy throttle. Shaft play and seal failure. Metal galling turbo spools without fluid film. The actionable fix. Change your starting routine immediately. When you start your truck on a cold morning, let the engine idle for at least 45 to 60 seconds before you shift the transmission into gear. This allows the oil pump to clear out any air pockets in the lines and establish full pressurized lubrication to the turbo center housings. Once you begin driving, keep your foot out of the throttle for the first 2 to 3 miles. Drive with light, conservative throttle inputs until the engine coolant and engine oil temperature gauges on your instrument cluster reach their normal midpoint operating ranges. If your truck is equipped with factory remote start, use it, but understand that letting the truck idle for 10 minutes does not warm up the turbos completely. You still must avoid aggressive, wide open throttle acceleration until you have driven the truck for a couple of miles and allowed physical heat soak to equalize the tolerances. The warning sign. Ignoring wastegate actuator tolerances, while the previous items are driver habits and software flaws. This final item is a critical maintenance blind spot that owners ignore until it results in total turbo destruction. Neglecting early mechanical warning signs from the wastegate linkage. The wastegate is a highly critical internal valve that regulates boost pressure by allowing excess exhaust gas to bypass the turbine wheel. On both the first generation and second generation EcoBoost engines, the mechanical linkage connecting the vacuum or electronic actuator to the internal wastegate flap is a notorious wear point, over thousands of heat cycles. The metal bushings and the pinhole on the wastegate actuator arm suffer from severe oxidation and physical friction. The hole gradually elongates from a perfect circle into an oval. When this tolerance slops out, the wastegate flap begins to flutter violently against the cast iron turbine housing whenever the engine is idling or under light deceleration. Ford is well aware of this engineering oversight. They even issued Technical Service Bulletin number 25-2208 to address a widespread wastegate rattle on newer models, requiring technicians to install a specialized mechanical wave spring kit, part number RL3Z9G488D, to stop the loose tolerances from destroying the assembly if you ignore the distinct metallic chattering or rattling noise during a cold start. The problem gets rapidly worse. The loose linkage eventually binds or seizes entirely. If the wastegate seizes in the closed position, the turbos will experience an uncontrolled overboost condition. This forces the turbine speeds past 180,000 RPM, spiking combustion temperatures, blowing head gaskets, or sending a connecting rod straight through the side of your aluminum engine block. Linkage bushing wears gall actuator arm develops, play gall wastegate flutters rattles. Engine damage or turbo seizure, linkage seizes binds. The actionable fix. Pop your hood and listen intently during every cold start. If you hear a clear metallic buzzing sound that sounds like a loose exhaust heat shield vibrating under the truck, do not assume it is harmless. Reach down to the turbocharger assembly when the engine is completely cold and physically shake the wastegate actuator linkage arm. If it has perceptible play or wiggles freely, it must be repaired immediately. You can purchase aftermarket wastegate linkage clip kits or spring tensioners for under $20 that pull the slack out of the loose arm and stop the destructive fluttering. Catching this tolerance wear early prevents the internal flapper valve from destroying its seat inside the exhaust housing, saving you from having to buy a completely new cast iron turbocharger assembly. We have unmasked the precise engineering traps, the software flaws, and the mechanical vulnerabilities that turn these highly capable truck engines into ticking financial time bombs. But there is an even more volatile mechanical contradiction hidden deep inside the EcoBoost's electronic throttle map that triggers sudden, catastrophic structural failure without a single moment of visual warning. Setting 0, low-speed pre-ignition, LSPI, and the lugging trap. We have covered the maintenance intervals, the cooling habits, and the software traps. But this final mechanism is the most deceptive, destructive, and misunderstood phenomenon in the entire world of modern internal combustion engines. It is a silent killer that does not just slowly wear down your turbo bearings over time. It can instantly snap a connecting rod, shatter a piston, and send a cloud of metal shrapnel straight through your exhaust path, completely obliterating both of your turbochargers in less than a single millisecond. I am talking about low-speed pre-ignition, commonly known in engineering circles as LSPI, and it is triggered by a driving habit that most truck owners think is completely harmless or even beneficial for their fuel economy: lugging the engine. Many truck owners operate under the old-school assumption that keeping engine RPM as low as possible while forcing the truck to pull a heavy hill or accelerate is the best way to drive. They think they are saving fuel and saving the engine from wear by not letting it downshift. Furthermore, Ford's factory transmission calibration heavily encourages this behavior. To chase higher EPA fuel economy ratings, the SelectShift 10-speed automatic transmission is aggressively programmed to short shift. It wants to get your truck into 8th, 9th, or 10th gear as fast as humanly possible, dropping your engine speed down to a quiet 1200 to 500 RPM. Here is the engineering trap. When you are cruising down the highway at 60 miles per hour in 10th gear at 1300 RPM, and you step firmly on the gas pedal to pass a vehicle without forcing a downshift, you are putting the engine under extreme load at ultra-low engine speeds. To deliver the power you are demanding, the engine control module closes the wastegates and commands the twin turbos to cram massive amounts of compressed air into the cylinders. This creates an incredibly high brake mean effective pressure, BMEP, inside the combustion chamber. Under these precise conditions, high boost, low RPM, and extreme cylinder pressure, something catastrophic happens before the spark plug even fires. The extreme pressure and heat cause microscopic droplets of residual engine oil mixed with fuel vapors in the cylinder crevices to spontaneously ignite. This creates an uncontrolled, premature explosion while the piston is still moving upward on its compression stroke. When this premature explosion occurs, it collides directly with the upward momentum of the piston. The resulting pressure spike is violent and astronomical, frequently exceeding 2,500 pounds per square inch. This is double the pressure of normal combustion, low RPM, high gear, heavy throttle input, Gall turbos, force max boost, high cylinder pressure, piston rod failure and turbo destruction, 2,500 plus PSI pressure spike, spontaneous oil fuel. Explosion. The physical impact of this pressure spike creates an instantaneous mechanical shockwave. It hammers down on the piston crown, bends or snaps the forged steel connecting rod, and shatters the piston ring lands. When that piston disintegrates at highway speeds, chunks of aluminum and broken piston rings are instantly blasted out of the exhaust valves. Where do they go next? They go directly into the exhaust manifold and slam straight into the precision-engineered, ultra-thin Inconel turbine wheels of your turbochargers, which are spinning at 150,000 RPM. In less than a second, a bad driving habit destroys your entire engine block and shreds both of your multi-thousand-dollar turbos simultaneously. The deceptive illusion, driving in high gears at low RPM, feels smooth, quiet, and fuel-efficient. The engineering reality, it creates extreme cylinder pressures that trigger violent, premature LSPI explosions, the fatal chain reaction. Exploding pistons send jagged metal debris directly into the high-speed turbo turbines. The economic standoff, forcing your truck to lug in 10th gear, might save you a mere 2 miles per gallon on a single road trip. That equates to about $5 in fuel savings. The cost of a catastrophic LSBI event is a brand new 3.5-liter long block engine, plus 2 brand new turbocharger assemblies, totaling anywhere from $11,000 to $16,000 in parts and labor. It is the single most lopsided, dangerous financial gamble you can make with a vehicle. The actionable fix: do not let your engine log down and struggle under load at low RPM. If you are towing a trailer, hauling a heavy payload, or driving through hilly terrain, always lock out your top gears or engage tow haul mode. On the side of your factory shifter, or on the steering wheel controls, there are physical .not and .none buttons. Press the done-in button to manually lock out 9th and 10th gears when driving around town or pulling grades. This forces the transmission to stay in a lower gear, which raises your engine speed above 2,000 RPM. Running at a slightly higher RPM drastically drops the internal cylinder pressures, completely eliminating the conditions required for LSBI to occur while keeping your turbos operating safely within their intended aerodynamic maps. Additionally, always ensure you are using an oil certified with the latest APISP or ILSAC GF6A standards. These modern oil formulations are specifically engineered with advanced chemical additives designed to suppress and prevent LSBI pre-ignition events in gasoline direct injection turbocharged engines. The definitive EcoBoost Turbo Preservation Guide turbocharger failure on the Ford F-150 EcoBoost is not an inevitable design flaw, nor is it a symptom of a weak engine. It is the direct consequence of operation habits and maintenance protocols dictated by marketing departments and fuel economy regulations rather than mechanical longevity. If you treat this highly sophisticated twin turbocharged powertrain like an old naturally aspirated tractor engine, it will punish your wallet severely. If you treat it like the high-performance, precision engineering piece that it actually is, it will easily run past 200,000 miles on the original factory turbos to protect your investment and keep your truck completely out of the repair shop. You must implement these 5 mandatory maintenance rules starting today. Killer habit: setting the internal mechanical damage. The simple actionable: fix 10,000-mile oil monitor carbon buildup, thin oil film, clogged intake screens. Oil starvation: chant oil every 5,000 miles, 3,000 to 4,000 miles if towing, using 5W30 full synthetic fluid. Unfiltered PCV loop sticky oil mist coats intercooler, turbo housing, and intake valves. Install a high-quality oil catch can to trap contaminants before they enter the turbos. Immediate engine shutdown: oil coking, baked carbon crust on mirror-smooth bearing surfaces. Idle the engine for 60 to 90 seconds after hard drives. Or install a mechanical turbo timer. Auto start-stop feature hundreds of unpressurized micro-cold starts wearing down thrust bearings. Disable the system on every drive manually. Or install an auto-stop eliminator kit. Cold start abuse structural metal binding and severe shaft play due to zero boundary lubrication. Idle for 45 to 60 seconds on cold starts. And drive conservatively for the first 2 miles. Engine lugging. LSPI, astronomical cylinder pressure spikes that shatter pistons and shred turbine wheels. Lock out upper gears using the Lian button to keep RPMs up. And use API-SP certified oil. A final warning to the owner: the automotive landscape is full of manufacturerly recommended settings designed to get a vehicle past its basic powertrain warranty window while looking highly attractive on a corporate cost of ownership spreadsheet. The factory oil life monitor, the aggressive transmission short shifting, and the constant engine cycling of the start-stop system are all engineered to satisfy regulatory metrics, not to guarantee that your truck survives to 250,000 miles every single time you choose convenience over mechanical discipline. You are shaving thousands of miles off the lifespan of your twin turbocharger system. The damage happens silently, atom by atom, bearing surface by bearing surface, completely undetected by your dashboard warning lights until the fatal moment of total mechanical failure. Take control of your truck's maintenance. Stop letting factory default settings destroy your hardware. Change your oil on time, let your turbos cool down, disable the electronic traps, and drive with mechanical empathy. Your F-150 will reward you with relentless power, incredible capability, and a complete absence of multi-$1,000 dealership repair bills. If you want to keep protecting your vehicle investment and uncover the real mechanical truths that corporate manuals try to gloss over, make sure to subscribe and turn on the notification bell. Leave a comment below letting me know if you are still running your factory oil life monitor or if you have already installed a catch can. Let me know your current mileage, and I will see you in the next shop breakdown.